Okay, good afternoon. Nice to see you again this year without face masks at the end. I'm Miguel García-Hidalgo, and I defended my thesis 2 months ago. So I'm going to talk about what I was involved in the last 3 years. And I'm from Soria, and I work in the Cambium research group since, I think, 7 years, at least. And I started my professional career there as a technician, and working in this research group that is involved in the response at secondary growth of trees and forests, depending on different environmental conditions, biotical and abiotical conditions. So we are trying to disentangle the relationship between the environment and forests with dendrochronology. Well, as I started as research technician, I was working with cores, with this course that Elena mentioned, and with tree ring, with early wood, late wood, these kind of things, and other proxies like microdensity that is well related to the response of the secondary growth to the drought, for example. And at the end, with quantitative wood anatomy. That is the main task in this area is to count cells, to count vessels, to count parenchyma, radial cells, and all these things related to the environment, and telling the difference between different years, different size or precipitation or temperature, and how they limit the tree growth. So I was tired to counting vessels, counting rings, counting everything that you can count in wood. And then I started my PhD and trying to solve these things. What the main thing is that music saved my life in the lab. So as the count counts, I like music. I think you do. And as you can see, music has changed along these years, along this century. So you can see in this image how musicians recorded the songs a few years ago, almost 1 century. And below this image, you can see the main spectrum of some song. And it's really similar how we plot our ring widths and other kinds of things in wood. And that's what made me think about it. We relate these curves, these ups and downs in ring width, with the environmental factors. The same as when we listen this spectrum, we can tell the difference between different instruments, a trumpet, a guitar, a bass. But we are in 2023. And the music changed, and dendrochronology must change. So we developed one tool to capture high-resolution images from wood cores, from wood samples, to know with anyone in a computer how to develop any dendrochronological task. Then we developed an open source tool with hardware and software that can increase the resolution of the old-fashioned tools to digitize into the modern world. Now this tool is installed in almost eight of the principal labs around the world. In Russia, the USA, South America, around Europe, and Africa. So that it was the first publication of my PhD thesis. Secondly, we can differentiate, when we listen into a song, we can differentiate or tell the difference between different instruments. And that's one point that the chronologist likes to do. We want to know which is the role, or at what extent is the role of precipitation, of temperature, of the growth of any surrounding trees around our study tree. That's why we developed a software with which you can analyze these densitometric results that we obtain from X-ray. And we can relate this maximum density for each ring with any of the environmental parameters that we want. And the same for the low density or the minimum density values. And it is the same that our ears can tell the difference between high pitch or low pitch in any song. At last, tired in the task of counting, we decided to develop two different tools, taking into account the modern development of deep learning methods, with which you can train these images with segmented or tagged images in which you can segment each visual or each ring, and then train any algorithm to do this task. By the way, on the night, every day, you put the algorithm to work, and then it works. You don't have to count anything. You only have to check. And it saves a lot of time. We developed two different algorithms related to ring segmentation and to vessel segmentation in non-conifer wood. That is a really hard task to do. And you have to train a really specialist person to do it. And it's a really repetitive work. Because if there are classical methods about telling the difference between high values of red or green or any kind of color and low values, but it is not good. It is not as good as a technician can do with your trained eye. But deep learning can do it. If you retrain these algorithms, they get better and better again. So they are learning. They are learning when you are using it. So these tools, all these tools that we published, are free open source tools that are available for everyone who is interested in this area. At last, those tools make the base to new developments, because as open software tools, anyone can develop, can train, can readapt this software, these tools, to their own objectives, to their own goals. Then we will be able to translate this thing that is a piece of a song into notes, that each note we know what is sounding, what are we listening into. This song that you have heard about all this presentation, I think you really know which is one. So thank you very much.